Hello, everyone. Welcome back to another episode of Learn with Dr. G. That's me. I'm really excited because we're finally starting the What You Didn't Learn in School series, where we're going to be talking about different things that sometimes are assumed when you're taking a formal class that you might already know. Now, there's a lot of resources online for them, but sometimes it's useful to just kind of get a guide through that. So we're going to talk a little bit about that today and for the next couple streams. So stick around. As always, I want to remind you of our code of conduct. Essentially, we just want y'all to be kind and friendly. We are all here to learn and just have fun and form a community. Hello, everyone. Nice to see you all. Awesome. And yes, I can see the chat for everything. So if you're watching on Learn TV or any of our YouTube channels or Twitch, I can see you all. So feel free to ask questions or make comments. So today we're going to be kicking off this mini series with the introduction to Git. So this learning path here, which you can find at aka.ms/learnwithdrg/intro to Git. This is the first module in a short learning path where you get introduced to the basics of Git, which we'll talk about today. So if you have questions about it, please be sure to ask, and I'm happy to help out. Over the next couple months, actually, we're going to be diving into Git, GitHub, some VS Code extensions, PowerShell, Bash, WSL, which is the Windows subsystem for Linux, and some APIs, and possibly some ARM. So yeah, I'm really excited about it. Hello, everyone. Hello to Brazil. Nice to see you all. So if you want to follow along with this, you can head over to aka.ms/learnwithdrg/intro to Git. And we're going to jump into kind of the exercises in a bit here. But you're welcome to follow along. You don't need anything else installed for this stream. Everything can be done inside of your browser as long as you have a Microsoft Learn account. So an account, it's free, it's a Microsoft account. You can sign in to Learn with your Microsoft account and you should be able to use everything. Hello to China. Good afternoon. All right. As I mentioned, this is part of a mini series on what you didn't learn in school. And I did create this short little playlist here for all of the videos that are going to be in this mini series will be in that short playlist. So if you want to follow along kind of in the whole series and the videos, you can do that by heading over there. Okay. And that's at Learn with Dr. G, aka.ms/learnwithdrg/WYDLIS, what you didn't learn in school, _videos. Hello from the other side. We shouldn't let me start singing. Okay, so let's talk a little bit about Git. I'm going to be taking a look at the comments and kind of just trying to chat with you all. So let's talk a little bit about Git and what Git is. Maybe you already know some of this, and if you have some additional information, feel free to put comments, put info in the comments, and we can all learn things together. So Git is essentially a way to, one of the primary ways you use it is to collaborate with others on software projects, on code. It is also extremely, extremely useful for projects that you're doing yourself. I don't know about you, but when I'm kind of building a large project that's going to take more than 10 minutes of me sitting at my computer, there's going to be different parts to my project that I'm thinking of. I'm going to have different points at which my project is kind of like a checkpoint where it's kind of complete enough and it's working. and then I'm going to start on like a new feature or a new part of it, right? So the way that I like to develop software is always thinking about that. Now I just, there we go. That MVP, I was going to think MVP, and then I started thinking the MVP program at Microsoft, and I'm like, that's not what I'm trying to say. It is MVP, the least viable, most minimum. What does the M stand for? Minimum viable product. There we go. MVP, minimum viable product. I'm going to put that in a banner. MVP, minimum viable product. The reason I like to think about it like that is I was a part of a startup. I also was in grad school, and then I also worked at larger software companies. And inevitably, deadlines always crept up. And so rather than trying to cram in to meet some kind of deadline that definitely existed and was very important, I always made sure to have multiple points where I could kind of stop and say, at the very least, this works, this can be shipped, maybe some features are missing, maybe it's not exactly what I wanted, but at the very least, this is a complete functional piece of software. So that's always how I like to build software. And awesome. If you know how Git works and you can't sleep, please help others learn too. Thanks for joining. Yeah, we got there eventually. Buffering, exactly. That's me all the time. So I always like to make sure that I'm kind of at that point. And Git is just kind of the way that allows me to ensure that if for some reason I got to that point and then I started, going on to the next part and ran out of time, I could always just kind of ship that last point. And rather than kind of having to save that code off to the side and then like copy it and continue working, you can use something like Git. Essentially, Git is version control. So it is controlling, it's kind of like understanding at every version of every file in your entire project. It is very much focused on files, not necessarily like directories, and we'll kind of get into that in a little bit, but really focused on files. And like I said, you can use Git completely on your own machine, nothing else. You can use Git kind of in collaboration with servers, such as GitHub is an example of a hosted Git that you can then connect with. And yeah, that's pretty much how you can use the two. And then, so you can use it in collaboration with like GitHub, for example, which we'll get to in a later stream. And you can use it with other people. So on one computer by yourself, with a server by yourself, with a server with other people. I guess technically on your computer with other people, but that's just kind of strange because if you're all on the same computer, you don't really need it. Not only do you kind of get those checkpoints, but you also get to add additional information about where you are when you're making those changes and kind of what those checkpoints represent. It also lets you quickly be able to see what changes have happened since the last time you looked at a particular file, which especially if you're working with other people is very useful. But even if you're working with yourself, just on a project by yourself, and you've, let's say, made some changes and you forgot what you had set that like random number to, but it worked that one time and it's not working now and you can't figure out why, you can kind of do a diff and see those. All right, I'm reading some of these. Yes, so a solution for version control for things that are kind of more than code, that can get kind of tricky. There are, I don't know all of the kind of solutions here. There are some support in Git for non-code programs, but you kind of need an additional layer where you kind of turn it into something that is essentially text-based and not like object-based. I've actually seen the ability to have like diff files on images, for example, and we can look into that in the future too. All right. It also helps if you can Git blame people. Yes, we'll talk about that in a future episode as well. All right, so version control. Let's kind of talk a little bit about how version control works. There's in this Learn module, there are a bunch of these 3-letter acronyms or TLAs. TLAs, I learned that term when I started working at Microsoft. It's like a pretty much, I can't remember how to spell acronym. Does it have an extra N at the end? No, it doesn't. Okay. For some reason, I thought it did. I thought that was pretty funny because TLA is a 3-letter acronym. And those can get confusing. So if you've ever heard of VCS, that's essentially a version control system. If you've ever heard of CVS, that is a concurrent versions system. You might have heard of SCM, which is a software configuration management. You might have heard of SVN, which is subversion. Yeah, CVS, it's a pharmacy. That's the first thing I think of. Or Perforce. So all of these are different types of version control systems. However, things like CVS, SVN, and Perforce are actually centralized server types of version control systems where all of the code always exists on the server and you don't have this kind of local copy. So every kind of all of the source of truth is on that server. So if for some reason you lose access to that or it goes down, then you have that single point of failure. Git, on the other hand, is distributed, which means you essentially have a server, or you could have a server that has the source of truth, but then you could also have a local copy that's your own source of truth, and everyone else who has access to that project can also have a local copy that is their source of truth. And then you can decide how you want to relate all of the above. We'll get into that when we talk about GitHub as well. So one of the best ways to think about Git is, and I think I've got this image here that I wanted to bring up. So let me just walk you through this really quickly. There is this great website, which is basically the Git documentation website. It's at git goodness gracious, git-SCM, I hate 3-letter acronyms.com. Hello. So you can head here. And someone was asking how many participants are on the Learn TV. So I got distracted because I was trying to check the comments for Learn TV. I'm not sure how many are on right now, but nice to see you on Learn TV. So the Git documentation has amazing documentation that you can walk through. It's got this reference manual and essentially like a book and a bunch of videos. So you can go check those out. One thing that I like to look at is this one here. So this file right here, or this page right here kind of walks you through what files could look like at different versions. Like where you might have a working directory, a staging area, or your Git directory, which is the actual repository. So you might, on the server, have your Git directory. You would check out the project to your working directory, which is on your local machine. Then you would stage fixes to the staging area. And when you're ready, you would commit all of those fixes to that working directory. We like to reference trees when we're thinking about Git, because that's kind of how we think about it. We have this one source of truth that is the Git directory that's typically on the server. And then you can have multiple people have branches off of that tree. And each branch represents kind of a version of that directory. And then you can kind of bring it back up. I forgot to bring this one up, but there's a GitHub, how GitHub Works page that I absolutely love. And I'm said I didn't have this. Where did I find it again? Why can't I find this? github.com. And then you can go to, it's like on the about. I don't know. I'll try to find it in just a second. But essentially, we kind of think about it like a tree. All right, sorry, reading through this. Is this the first episode? Yes, this is the first episode of the What You Didn't Learn in School, focusing on Git. Push, pull, commit. Yes. Wait, push, pull, commit. Pull, commit, push, maybe. I am not talking about Xbox controllers. Yes, Git allows us to be more agile. And where lives staging area, RAM or hard drive? Oh, good question. I mean, it lives on your hard drive for sure, because it's actually stored on your local machine. I mean, things will be brought into RAM as you're working on them, but yeah. There's another picture. Nope, there isn't another picture. Yeah, so we kind of think about these working trees because that is going to be that main project that you're working on. And your working tree is basically that, your repository is basically that high-level directory that has all of your files in it that then contains all of your working tree. One of the best ways to see this is to actually do it. So in the future on this mini series, we're going to talk about the Git integration with Visual Studio Code and also with GitHub and other GitHub tools like GitHub Desktop. But for now, we're going to actually jump into what is called the sandbox in Microsoft Learn. Push from the working copy, pull, fetch from local repository. Yeah, we'll get into the language in just a second. So this is a really great resource for you. Again, this is going to be on the learning path, which you can find at aka.ms/learn-with-Dr.G/intro to Git. So if you want to follow along and do this as well, we can do that. Oh, there's a link right there. Perfect. And then we're going to activate this sandbox. And this basically uses Azure Cloud Shell to give us this interface on the right-hand side that's not only going to give us a terminal, but also allow us to open a version of Visual Studio Code all within our browser. It's not that GitHub code spaces. This is just an integrated experience with Microsoft Learn, which you'll see in a second. Yes, there will be a schedule for streams for the next episodes. And actually, you can find that on my, I'm trying to do this effectively, but you can go to github.com/Dr. Guffels, where I am trying to have this be clear so that you can kind of keep up to date with what's going on. So here are a couple, and I plan on adding more in the future. So once our sandbox is activated, you can have up to 20 sandboxes each day, and you get 2 hours per sandbox when you initiate them or activate them. So I'm using sandbox number 3 for today, because I obviously wanted to make sure that I was testing all of this out before the stream also. All right, so right now we've got this terminal over here. And if you're unfamiliar with the terminal, basically this is a text-based version of your files on your computer. So right now, if I type in ls, that means list, like list all of the files. So that's the equivalent of double clicking and looking at a folder and the contents of a folder. We're going to follow through this right now. This is just a temporary machine. It's not something that you can have access to later. It's just for the purposes of testing. The GitHub client for Windows, yeah, we'll talk about GitHub in a future one. I really like GitHub Desktop, which works on Windows, Mac, and Linux. And yeah, I love this as a sandbox for trying Git commands. It's one of my favorites, and I'm so glad that they integrated this into that. And yes, I also love Mac users. I'm an all of the above user. All right, so git -- version will just ensure that we have a version of Git installed. So if you haven't installed Git already on your local machine and you're trying to do this on your local machine, not in the sandbox, then you need to make sure you install it. And then you always want to make sure you know what version you're working with, and always update when you can. So the next thing that we're going to do is we're going to configure Git. And this is important because if you're going to commit code to a repository, to a Git repository, then you need to be able to, Git needs to be able to assign that commit, which we'll talk about what a commit is in a second, to you and your email. So then that way, if something goes wrong, people know who made that commit, okay? So the first thing that you always want to do when you're setting up Git on your local machine is set your configuration file, specifically your name and your email. So I'll copy this and paste it. Oops. How do you paste in? Paste in here? Yeah, there we go. And we'll go ahead and change this to Dr. G. Dr. P. And then we can set our email. And since this isn't actually real, I'm just going to say drg@email.com. Perfect. Again, you want to put your real stuff in there when you're doing this for real on a real project. For this purposes, it's not going to go anywhere, so we don't have to worry too much. Sorry, reading through this. Pick the computer and OS that suits you. 100% agree, definitely. For people who didn't understand VCS, I think I missed your first comment. Version control system. Yes, that's what this one is all about. Oh, here we go. Centralized version control system are characterized by a privileged repository managed by a server. Yes, that's a great explanation. Thank you for helping. Is source tree a bad thing? I don't think so. I actually can't remember. Awesome. Thank you, Mohammed, for adding additional comments. If you're watching on that same YouTube channel, great explanation. Thank you. So now that we've configured Git so that it knows who we are, we're ready to start writing some code and seeing how Git handles our code. So again, remember, the point of Git is to have a source of truth and to be able to track changes that are relevant and then to be able to kind of go back and forth between those changes. So in this example, the first thing that we're going to do is we're going to create a directory called cats. So mkdir means make directory. And that's the equivalent of creating a new folder, right? So meaning list, you can see that I do have this cats folder right here, and I didn't have that before. Then I'm going to go cd cats. cd is change directory. So that's the equivalent of kind of double clicking open into a directory or folder. And now you can see that I am in that directory called cats, whereas before I was in my home directory, which is represented by this tilde. So in order to tell Git that we want to track any changes that are happening within this folder, aka repository, we need to type git init. So that's going to initialize this folder as a Git repository. All right. Hello, everyone. All right, we'll continue. Another really useful command, and one that you would probably use pretty often, is called Git Status. And let's kind of zoom in down here so we can see this a little bit better. So Git Status will tell us the status of our local copy in comparison to what has happened since the last time we have synchronized with the kind of source of truth. So for example, we are currently on the main branch. We have not made any commits yet, and we have not made any changes to our local files that we might want to commit. Notice that it does give us this little kind of snippet here that says that if we do want to create and or copy files, then we might want to do git add. Git add is going to tell Git that that file that you're going to add is one that you want it to track. So now it's going to pay attention to that file, and anytime you make a change to that file, it's going to show up down here to say, hey, you've made a change to this file. You might want to consider committing it. How can you move up one folder? Great question. If you do cd ... cd ... like this, and that says go up one directory. If you did that and typed ls, we can see that, sorry, can't really scroll down. I think it's because I'm like a little bit. Now you can see that we're at that top one. If you did pwd, that is what is our path of our working directory, pwd path of working directory. So the working directory that we're in right now is home/Sarah. And when we did cd cats, our path of our working directory was home/Sarah/cats. You can do ls-a, which gives us, also shows us all of the hidden files within our directory. So do you see the dot is our current directory. The ... is the directory above. And the .git is a hidden folder that contains all of the things that Git is kind of like paying attention to. It basically contains that. All right. If you type git -- help, you will get all of the Git commands that are most likely going to be useful for you. There's a bunch of other things that you can check out on that git-scm.com documentation website. But this is also just a really useful thing in case you're forgetting some of these commands. When we go over to the next unit within this module, it's not going to show us the sandbox, but when we go to the other one that does have the sandbox, that's when we're going to get into, or it'll save kind of your progress between them. How to delete a folder. We are going to do that in just a minute. What is the equivalent command for ls-a for Windows? Good question. It's dir, let's see. Are you in PowerShell? Check this out. Equivalents for common Linux bash commands. Looks like this might help. I'm not exactly sure. Even when I'm on Windows, I actually use WSL. So then that way I can stay in a bash command prompt. But yeah, you can take a look at that one. Is it possible to have multiple emails in the Git configuration? Oh, great question. Yes, I'm pretty sure you can you? I'm pretty sure you can. I think I've done this before. Multiple emails in Git config. Let's see. Using Git with multiple emails. It is a problem because then it can't kind of do that. But yes, it does look like you can have a particular directory that has its own Git config file that has one type of email, and then a different directory with a different Git config file with a different email. Yes, definitely can link this page. Great question. Oh, and then I think you might have been asking for that other page. Oops, this one. Those are the two I just found. Okay, so let's talk a little bit about what we can do with Git. So right now, all we've got is this folder no files in it yet. And we're going to write some HTML and CSS files in just a second, super basic stuff. And then we want to start to understand how it's connected up with our Git repository. So we know that Git status will tell us kind of the status of all of the things that have happened on the like hosted version within our local version that we've committed, and then things that we've changed that we haven't committed. We saw that git add will tell Git, hey, this file that I want to add, pay attention to this one, because anytime I make changes, I want you to remind me that I probably want to commit it. And then what is a commit? So if we go back to the Git source code documentation, we can actually see that this staging area here, sorry, this is staging fixes. So committing basically says that, so if you've made changes, right, so you've saved things, when you commit, it's still on your local machine, okay? But you're saying that that is a change that you want to save. Like, this is data that is safely stored in your local database, not just in that file, but in your Git now knows about this. And if you made changes, so let me say this a little bit better. Write code, make changes. Commit those changes. Git now knows about those changes over here. I'm going to keep writing code and save on my computer. Then right here, I'm like, oh no, I messed up. All of this code right here, totally messed up with that. I need to revert my code back to this point. And instead of doing undo, 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 I can just go over to Git and say, hey, can I get that code again? And I can revert my code back to here. And so Git still knows about this, and then I can kind of get rid of all those and restart. Does that make sense? And you can do that with multiple, right? So we can actually kind of draw this out a little bit. If you have a file and then you make some changes, we'll put changes in red, right? And then you commit that file. So Git now has that file with those changes. And then on your machine, this is still your machine though, you make some additional changes. And then you're like, oops, nope, did not want that. Nope, nope, nope. Then what you can do is you can say, hey, you, can I please have you? Can I have that back? And then it'll say, yeah, no problem. And it'll give you that. It's basically what I'm trying to say. And we'll see that in action. We'll see that in action in just a second. Now I've got marker all over my fingers. That's okay. Yeah, so Control S is like saving it to your local machine, and a Git is like Control S for Git. It's a great way. All right. Awesome. Thank you. All right, let's keep going. A couple other commands. Git log will just give you a log of all of the commits that you've done in the past. And then we already saw Git help. So yes, no problem until merge conflict. Don't worry, we'll get to those in the future. So we're back to our Azure Cloud Shell again. Look, we still have our 1 hour and 44 minutes of our sandbox. So that's good. So now what we're going to do is we're going to actually create a new file called index.html. And one way that you can do this in Azure Cloud Shell is just by saying touch index.html. And you can see here an explanation for what this does. So it either updates the last modified time. That can be useful for a lot of reasons, but basically kind of like the relevance of that file. Or it creates an empty file if the file does not exist, which is what we're going to use it for. So we'll type touch index.html. Let me get rid of this banner so you can see a little bit better. Sorry that it's hard to zoom in here with the kind of see that a little bit better. So we'll do touch.index.html. And now if we do ls to list, we can see we have an index.html file. if we did Git Status here, Git Status will tell us the status of kind of that repository. So let's go ahead and check that out. So what we can see here is that we are currently on that main branch. We still have not committed anything, right? We created this file, but we did not commit that file. All we did was create it. And we have untracked files. Index.html is an untracked file because we haven't even told Git to add it to the list of files that it's watching yet. Okay? Which means we cannot commit that file because Git doesn't know about that file, right? Even though that file is new and a change, Git doesn't know about that file. So we can't commit it yet. We have to add it first. All right. Just checking on the comments. Perfect. Okay, so next we're going to say git add dot. Git add dot. And this is one way that you can add all of the files in your local, and your current working directory or your current folder, add all of the files to Git to track them. So if you remember up here, when we said ls, oops. Oh my goodness, where did you go? Oh my gosh, I think I just closed my window. Awesome. I don't know how that happened. Oops. All right, let's go back to here. I don't know how that happened, but in any case. Still trying to sign me back in. When we did ls-a, when we saw that dot, and then the cats folder, that dot is our current directory. So we've got that. I think this is still the same sandbox. So I'm hoping that it loads it up again. Same one. I'm not sure if it will. So when we do git add and then space dot, then we can add everything in that folder. But you can also do git add and then a specific file. So let's say that you had a bunch of files that you weren't quite ready for Git to kind of pay attention to, or even some that you didn't want them to. You can specifically add certain files instead of all of them. Hello. Okay. Yay, we still have cats. And we still have Git in there. And let's do Git Status. Okay, so now when we do Git Status again, what we can see here is we're still on that main branch. We still don't have commits, but we now have changes that can be committed. So earlier we had untracked files that could not be committed. Now we have a new file, which is a change. This is that new file, and we can actually commit that change. All right. What if you wanted to add an empty folder? Yeah, we're actually going to do that. So we'll do that in just a minute. The next thing that we're going to do first, though, is we're going to actually make a commit. So we've made a change. Right now, index.html has nothing in it. It's just an empty file. So we're going to say git commit index.html-m, create an empty index.html file. So what this is doing right here is we're telling Git to make this commit of just this file. There is a way that you can actually do everything in your entire directory if you wanted to. So make a ton of changes and then commit all of those changes at once. But for now, we just have one file anyways. And then this -m is to say, I want to add a message to this commit. It is always, always important. And oh my gosh, I can't tell you how many times I've been like, oh, the message isn't that important. I'm the only one working on this. My message is going to be something like made a change, another change, small change. And it's so unuseful because then 20 small commits later, when I can't remember where that one thing is that I changed that one time, I can't find it. So have commit message. I promise you, it'll be useful. Have commit messages that are real, okay? So in this case, create an empty index.html file. So we'll go ahead and run that. And if we did git status now, what we can see is we have committed this. One file was changed. There were no insertions and no deletions. Insertions are like characters in a file that you've added. Deletions are characters in a file that you've removed. And so this is an entire file that was changed, like one new file, okay? And for Git status, we are on our main branch and there's nothing more to commit and we're working on a clean tree. So since this doesn't have a server attached to it, like a server version, we'll get to that when we do GitHub, for example. Once you commit, it's already kind of stored in Git and you're pretty much done. You can actually add directories. There is a way, but we'll kind of get there. Yes, so if you wanted to do all of the files in a directory, you just do dot. Although there is nothing in there because we haven't made any changes yet. Yep, exactly. Git commit -r. So here we can find all of the Git commit options. So, sorry, it's -a, not dot. -a stands for all. So AM would be all of them. So right here, it wasn't dot. I mean, I think you can maybe do, so but you would do -a. So -a would be all of the files that you have already told Git to keep track of. So if you did a Git add to all of those files, Git -a will do all of the files that have changes that you added to Git. Okay. Yes, the tree structure of Git. I'm actually gonna have a video of that on Friday coming out where I'm gonna have some animations and show it better than me drawing things on a whiteboard that you can hardly see. So we'll get to that one. Look out on Friday. It'll be in that same playlist, this one here. So if you are interested in checking out the tree structure of Git, that video will be coming out Friday. All right. One thing that we haven't done yet is Git Log. So again, like I said earlier, Git Log basically just tells us all of the commits that have happened. So this is that hash for that commit. It was committing from head to the main branch. This is who made that commit, and this is when it was made. And this is what the commit message was. And when we do more, we'll be able to see more of that. So now let's go ahead and open up our index.html file. Like I mentioned earlier, you can type in code index.html, and that's going to open a version of Visual Studio Code. As you can see, it's not all of Visual Studio Code, but it's kind of this version, so you can at least make some changes. So we can add in some HTML here, do Control S for save, or click on this and do save, and then close our editor. And now when we do Git status, we have some changes that were not staged for commit yet. We modified index.html. It's no longer a new file because it already knows about the file, so we modified it. So here is where we can say git commit -a-m, adding a heading to HTML, index.html. So the -a is going to say all of the ones that you've tracked, you are tracking. -m is our message. And we can continue to do that. So now we're going to say code index.html. And this time we're going to replace all of this with some better HTML. And before we commit, because Git has a representation of our file, and that representation has just that one header. And I want to know my file that I have on my local machine, because maybe I've been coding for like 10 hours straight. I want to know what is so different about my file compared to that one. Just before I overwrite that one and I commit that one, I want to know what's different. So that's when you can do git diff. And we can see here what git diff does. So right here, we have in the file that Git is tracking, we're going to remove this line of code. And then we're going to add these 12 lines of code. And notice right here, it says that we're going to get rid of 1 and then add 1 through 12. Okay. And in later videos, I'm going to show you with other ways of doing git diffs. GitHub, for example, has these really pretty ways of seeing it. Yes, the git commands. There you go. All right, so that looks good. That is the change I intended to make. So I'm going to go ahead and commit that. And we can do another git log, and we can see now we've got multiple commits that have happened. This is the latest one and the one that is represented on our main branch, but these are the other two that we did, that the adding the heading and then creating the empty file. Sometimes you want to be able to ignore certain files. It's very important. Like sometimes there are metadata files that we really just don't want to keep track of because they're just metadata for your local machine and they're not useful to the actual project. And in fact, they might mess someone else up on the project, or if you're switching between computers or things like that. So one way of doing that is by creating a git ignore file. And this is a special Git file that'll ignore anything with a .bak, and then also I think star tilde is like anything that is like in the home. I'm not actually sure. I can't remember what star tilde does now. I'll have to look that up. I thought I knew, and then now when I'm trying to explain it, I can't remember. In this case, there aren't any of those kind of backup files. That's what BAK is, backup files. We're using Git for that, but we're not going to have any right here, so that's fine. So let's go ahead and open up our index.html again. And let's change this one to furry instead of feline. And close it. And then let's do git add and git commit. So not only are we making a small change to the words, but we're also adding in that git ignore file. We needed to do git add -a because we wanted to make sure that we captured that git ignore file. So now if we did a Git Status and a Git Log, got that. And I shouldn't have committed before doing a diff, but that's okay. Okay, let's make another directory real quick. We're going to call this one CSS. Vim swap files append tilde to the file name. Oh, that's right. Thank you. Yep, swap files. I was like, I remember that, and then I couldn't remember what it was. Each commit should focus on one small task. Yes, agreed. Very good point. Each commit should focus on one small task. It's fine if you modified one file or 5. MS Office also has temp files with tilde. It should be one specific task, so then that way your commit messages are very clear. Yes, temp files. When we get into talking about GitHub in later videos, we'll talk about commits versus pushes versus pull requests, which is kind of a whole another layer to it. Okay, so this is where we wanted to create that directory. So Git Status, notice that we made a directory, but it says that there's nothing to commit. So like earlier, someone was mentioning, can we commit an empty directory? And someone was like, no, you definitely can't do that. No, you really can't do that. But you can kind of do that if you create what's called a Git Keep File, which is essentially a nothing file. It just essentially is a file just to tell Git that you really want to keep that directory, even though it is empty. You can actually create an entire file structure and have Git track that file structure that's just completely empty, but I don't know if it's, depends on your use case. Cool. My PhD's in computer science, focusing on education. So let's go ahead and remove that file though. So someone else earlier was asking about removing a file. Keep. So you can actually remove a file with RM. RM will remove that file. And now let's go into that folder and let's create a CSS. Oops. And let's go ahead and do that. And then let's go back up to here. And let's go ahead and add this into our head. Okay, so now we've made some changes. Let's go ahead and add those start tracking the new file, which is our site.css file. And then before we make a commit, we can see kind of these diffs. Oops. Git add. Git commit. And now we can see all of these files here. If it does show you kind of like a longer Git and then you push, it has the colon on the side and then you push enter to kind of continue to see it, you can click Q to escape from that and be able to continue on in your terminal. We can do Git Log -1 line, which will give us that Git log in a smaller way. And that's why these Git commits are super useful for you. All right. The next thing that we're going to do super quickly is actually fix mistakes that we might have made. So let's say you accidentally removed index.html. So now we have that CSS folder, but we lost index.html. What you can do is say git checkout -- index.html. So what we want to do is remember, we just kind of like deleted this one now, but we're in this point in time and we want to go back to Git and say, hey, can you hand that to me, please? Can you bring that back? All right. And then when we do that, our index.html is back. All right. If instead of doing rm index.html, you did git rm index.html, now you are actually removing index.html from Git. So now you kind of undid the add, which means if you tried to do git checkout index.html again, Git is like, I don't know what you're talking about because you never told me to track that, or you told me to stop tracking that, so I can't help you there. And that's where we might want to reset our head, which is Git's kind of like main working tree branch. We want to reset that for the index.html to what we currently have on our local machine. Because remember, our local machine, we want to reset it to the previous commit. And now we can check it out again and have it back. And then you can also like make another change. So you can kind of continue doing this stuff here. We can do that. So we replace all of our code, and then we say, oh my gosh, we're replacing all of our code. We're committing that we're purposely overwriting it on accident. And then here, we can look at the last Git log, just the last one. And we can check out again and open it. We can see that that has all of our bad stuff. That's our old stuff. That's our mistake. Because we made a mistake, we committed that mistake. And then when we checked it out, we're like, oh no, there's the mistake. So you can actually revert back again to a previous commit. And then now what happens, if I'm running out of time, so now I'm talking fast, but I'll finish talking about this in the video that I'll post on Friday. So we made a change where we overwrit the contents. We tried to, we checked out the previous commit. So then, and it was wrong, right? We're like, oh no. So then we said, let's revert that. I want to undo that. I don't want that change there anymore. So the newest commit is that we wanted to revert that change. So now if we were to check out again, we have our code back. So checking out will just kind of give you whatever is at the highest level, and then reverting will allow you to grab the previous commit message. Okay, sorry, I'm going to answer some questions super quick. I'm not sure how CSS is equal. Oh, right. So I had CSS on mine when I was showing it. I had it in lowercase CSS, and in the lesson it actually has all uppercase. It would make a difference, but I am not, we're not actually trying to run this code, so it's all okay. Difference between Git checkout and Git restore. Great question. I don't think I have time to answer that full question, but I'm going to write that one down as something that I should answer in the video Friday. Git is case sensitive, yes. Command to roll back to a specific commit. Yes, I will put that one in there as well. And yes, it is. So command to roll back to a specific Git, you do Git commit and then a specific ID. So we can probably do that in here quickly. Let's close this editor. Let's do Git log. Sorry, let me do Git log. Oops. Ah. I did this way too long ago. There you go. Oh, I put a space, that's why. So this like hash right here, that's what you can use in order to get a specific commit. So you can do a Git checkout or Git revert to those. Yeah, within the file. So basically over here, I should have, that was my mistake. This should be lowercase CSS because I saved mine as lowercase, or I created the directory as lowercase CSS. That was a good catch. I should have not done that mistake. And squashing commits. I can't right now because I've got 1 minute left. But yes, in the video, I will add in I'm going to go through these comments and anything I couldn't answer. I'll add some information in that in the next video. And then also you can watch the next couple of streams are still going to be on Git. So next Tuesday and the Tuesday after are all Git related things. So again, if you wanted to check out number one, if you could please submit a survey for us so I know if this is content that y'all want. But from the comments, I think it is. So we will continue to do things like this. And then also, if you could, Oh, if you have any other questions after this is over, please don't hesitate to reach out to me on Twitter at Dr. Guthels, hashtag Learn with Dr. G, and I will look through those and we can answer them in the next couple of streams. Otherwise, thank you so much for joining. I have to let go for the next stream, but I'll talk to you all soon. Bye.